Greetings and welcome to the Introduction to Astronomy. In this week's Misconception in Astronomy, we are going to talk about the seasons and find out if seasons are unique to Earth. So let's get started here. So what do we ask our question? Are the seasons unique to planet Earth? And the answer is very definitely no. In fact, any planet that has an axial tilt will have seasons. Now, Earth's axis is tilted by about 23.5 degrees. Other planets are tilted by varying amounts. Some are have very little tilt. Others have a much larger tilt than Earth. And that will affect the seasons. So it is this tilt, the fact that we are tilted on our axis, that gives us our seasons. And it does two things here. First, the altitude of the sun changes. Sometimes the sun will be higher in the sky. That's our summertime. And during the winter, the altitude of the sun will be lower in the sky. And you can see this if you go out at about noon in different times of year. You will certainly see that during the summertime, the sun is much higher in the sky. And during the winter, the sun is much lower in the sky. The farther you get from the equator, the more extreme this gets. The closer you get to the equator, the less extreme it will become. So the altitude of the sun will change, meaning that sunlight hits us more or less directly, and also the length of daylight changes. The days are longer in the summer, and the length of daylight is much shorter in the winter, giving the sun far less time to heat up the Earth. So what about other planets? Well, Mars actually has seasons much like Earth. The tilt is a little bit more, but about the same. And here we see an animation showing Mars's growing polar caps as they grow and shrink over the seasons. So we can see the North Pole and the South Pole. And just like on Earth, as one grows, the other will shrink, and they will alternate each other. And that happens here on Earth as well. So Mars would have seasons very much like our own Earth because the tilt is about the same. Now, Mercury and Jupiter have a very little tilt. They are almost straight up and down. That means their seasons are going to be much less extreme and will have very little seasonal activity compared to planets like Mars and Earth. On the other hand, the planet Uranus has a very extreme tilt, much more than Earth's. In fact, it's tilted by almost about 90 degrees, meaning that it's laying on its side. So it gets very extreme seasons where one side will be pointing to the sun for decades, and then we'll see no light for decades as Uranus orbits around the sun. So Uranus, a very extreme tilt, would give it very extreme seasons. So what we find is that the greater the tilt, the stronger the seasonal effects will be. The less the tilt is, the less the seasonal effects would be. So planet like Uranus, shown here, almost on its side would get very extreme seasons as it orbits the sun. One side would be in sunlight for a long time, and the other would be pointed away from the sun. Whereas a planet like Mercury, which is almost straight up and down, would have very little seasonal effects. So what are the seasons like? It really can depend on the specific conditions as well. A planet like Mercury, even were it tilted, would have less seasonal effects because it has no atmosphere to help hold in heat and allow for some of these changes. So yes, areas would be exposed longer or shorter times, but you would not see the big changes that you get here on Earth, for example. So let's go ahead and finish up with our summary. And what we've looked at today is that seasons are not unique to Earth, that they can occur on any planet that is tilted on its axis. So if it has a tilt, it will have some kind of seasons. In general, the greater the tilt, the more extreme the seasons will be, although specifics of the planet can affect this as well. So that concludes this week's Misconception in Astronomy on seasons being unique to Earth. We'll be back again next week for another Misconception in Astronomy. So until then, have a great day, everyone, and I will see you in class.